Hi students! For today's discussion, you will learn about differentiating permutation from combination of n objects taken r at a time. At the end of our discussion, I hope that you will learn to compare permutation and combination according to their meaning, order, answer, derivation, and formulas, and to compute the values of permutation and combination of n objects taken r at a time. So here is our comparison chart. So first is the basis for comparison. The second column is for permutation. And the third column is for the combination. So let us first define permutation from combination. So permutation refers to the different ways of arranging a set of objects in a sequential order, or order does matter. And in combination, it refers to several ways of choosing items from a large set of objects such that their order does not matter. Second one is their order. In permutation, order, placement, and position are relevant. But in combination, order, placement, and position are irrelevant. The third one is for the nodes. In permutation, arrangement, permutation denotes several ways to arrange things, people, digits, alphabets, colors, and many more. But in combination, the selection here for combination indicates different ways of selecting menu items, food, clothes, subjects, and many more. So let us continue to differentiate permutation from combination. So again, we have here the comparison chart. What is it? So in permutation, ordered elements, the permutation is nothing but an ordered combination. While in combination, it is unordered sets. Combination implies unordered sets or pairing of values within specific criteria. We have here answers. For permutation, answers how many different arrangements can be created from a given set of objects. While in combination, it explains how many different groups can be chosen from a larger group of objects. Basis for comparison, deviation, in permutation, multiple permutation from a single combination. Many permutations can be derived from a single combination. While in combination, single combination from a single permutation. Only a single combination can be obtained from a single permutation. Next, to our comparison chart, we have here example. Permutation, choosing a first, second, and third place winners from a beauty pageant. But in combination, we have your example of picking top 10 finalists in no order in a beauty pageant. And formula for permutation, number of permutations or order matters of n things taken r at a time. So again, here is our formula for permutation. Permutation of n and r is equal to n factorial over the difference of n and r factorial. While in combination, the formula, number of combinations or order does not matter of n things taken r at a time, combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. So these are the difference of permutation and combination. This time, let us compute the values of permutation and combination of n objects taken r at a time. So you can see here that we have the same given So the given is 6 for the value of n, and for the value of r, it is equal to 3. So let us try to solve first the permutation. So again, our formula is permutation of n and r is equal to n factorial over the difference of n and r factorial. So by substitution, we can now have here permutation of 6 and 3 is equal to 6 factorial minus 6 minus 3 factorial. And by simplifying, we have here 6 times 5 times 4. And the answer is permutation of 6 and 3 is equal to 120. Next, the given is the same, n is equal to 6 and r is equal to 3. But this time, we are going to solve for the combination. So, the formula for combination is combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. Substitution, we have here 6 and 3, or combination of 6 and 3 is equal to 6 factorial over the difference of 6 and 3 factorial multiplied by 3 factorial. And first, we have to simplify 6 minus 3. So, we have here 6 factorial over 3 factorial and 3 factorial, or 3 factorial multiplied by 3 factorial. Simplify the numerator, so it will become 6 times 5 times 4 times 3 times 2 times 1. And for our denominator, we have here 3 factorial times 3 factorial, so this will become 3 times 2 times 1 for our first 3 factorial. For the second 3 factorial, we have 3 times 2 times 1. And again, this is division, so we can have cancellation. So we can cancel 3, 2, and 1. And you can see here that we can simplify or divide 6 and 3 by 3. So 6 divided by 3 is 2. And 3 divided by 3 is 1. So you can see, or you can also see here that we can simplify 4 and 2. So divide it by 2. So the answer is 4 divided by 2 is 2. And 2 divided by 2 is 1. So the remaining numbers are 2 times 5 times 2 for our numerator. And we only have 1 in our denominator, so we do not write over 1. Just simply write the remaining numbers in the numerator. So 2 times 5 times 2. So our answer, combination of 6 and 3 is equal to 20. So again, if we have the given of n is equal to 6 and r is equal to 3, in permutation, we have the answer of 120. And in combination, we have the answer of 20. This time, let us try to solve more problems involving permutations and combinations. Example number 1, we have here the given of permutation 10 and 3. So, the solution, permutation, so we have to use the formula of permutation, which is permutation of n and r is equal to n factorial over the difference of n and r factorial. So we have here the value of n is 10 and the value of r is 3. So by substitution, we can now have permutation of 10 and 3 is equal to 10 factorial over 10 minus 3 factorial. So first is to simplify the denominator. So 10 minus 3 is 7 factorial. And if we are going to simplify the value of 7 or the 10 factorial, we have here 10 times 9 times 8 times 7 factorial. I end up with the 7 factorial because our denominator we have here, if we are going to simplify, so this is will be 7 factorial. And this is division, so we can cancel here the 7 factorial in our numerator and 7 factorial in our denominator. So we can now only have 10 times 9 times 8. So what is your answer? Correct. So the answer is permutation of 10 and 3. This is equal to 720. Very good. Or another way on how we can get the permutation of 10 and 3, that is, I already explained in our recent videos. So if we have here permutation of 10 and 3, so we will start at 10, and then we have here the value of r, which is 3. So 10 times 9 times 8. So this is also equal to 720. So let us move on to our example number 2. Given permutation of 7 and 4, so what is our answer? So we can easily find it by using the one that I already taught you in the recent video. So 7, we start at 7, multiply by 6, multiply by 5, and then multiply by 4. So what is your answer? So again, 7 times 6 times 5 times 4, what is your answer? Correct. So the answer here is 840. But this time, let us have our solution if we are going to use the formula of permutation. So by substitution, we can now have here 7 factorial over 7 minus 4 factorial, and 7 minus 4 factorial is equal to 3 factorial. So simplify 7 factorial. So this is 7 times 6 times 5 times 4 times 3 factorial. So I end up with the 3 factorial because the denominator is 3 factorial. So we can cancel 3 factorial and 3 factorial. So we can now have 7 times 6 times 5 times 4. So this is equal to 840. So whether you use our simplest method or the shortcut method or our formula, we can get the same answer. So again, it is up to you whether you use this step-by-step problem wherein you use here the formula or our simple ways in finding the permutation. Let us now move on to our example number 3, but this time you can see here that our given is permutation of n and 3 is equal to 504. By that time or this time, we need to find for the value of n. So solution, of course, we need to use the formula of permutation, and by substitution, we now have here permutation of n and 3 is equal to n factorial over n minus 3 factorial. Again, the missing here is the value of n. And next is 504. This is our permutation. So 504 is equal to, the denominator is n minus 3 factorial. So for our denominator, always start at n, followed by n minus 1, multiply by n minus 2, multiply by n minus 3 factorial. We should end at n minus 3 factorial because it is the value of our denominator. So next thing that we can do, again, this is division, so cancel n minus 3 factorial. We can now have here 504 is equal to n multiplied by n minus 1 multiplied by n minus 2. And we need to think of 3 consecutive factors where the sum is 504. So we need to think of 3 consecutive factors for 504. So you can see here, so we can have 8 times 63, and from 63 it is 9 times 7. So we can now have 8 times 9 times 7, or 9 times 8 times 7, or 7 times 8 times 9. So 504 is equal to 9 times 8 times 7, or 504 is equal to 7 times 8 times 9. And if we are going to find for the value of n, just look for its highest consecutive factors. So from numbers 7, 8, and 9, the highest is 9. So the value of n is equal to 9. So the answer is 9. Before we leave our given in number 3, so let us try to use another method, which is the trial and error method, or the TAE method. So I used to call it the TAE method. So again, we need to find for the 3 consecutive numbers that if we are going to multiply these 3 consecutive numbers, the answer is 504. So I list down numbers from 1 to 10 because we only have to find for the 504. So let us try first to multiply numbers 5 times 6 times 7. Again, the value of r is 3, so we need to find 3 consecutive numbers. So if we are going to multiply 5 times 6 times 7, what is our answer? $210 only. So this is not our answer. Again, we need to find for the 504. So what if we multiply, let us try 6, 7, and 8. Multiply 6 times 7 times 8. What is our answer? 336 only. So this is not equal to 504. What if we are going to multiply 7 times 8 times 9? What is our answer? Correct, 504. So that is our goal, 504, and our 3 consecutive numbers is 7, 8, and 9. So this time, we need to find for the value of n. Just look from these 3 consecutive numbers, what is the biggest number? 7, 8, or 9? Very good. So the value of n is equal to 9. So if we are going to use the trial and error method, n is equal to 9. And also, you can see here that if we are going to use the permutation formula, the answer is also equal to 9. So it is up to you whether you use the trial and error method or the permutation formula to get the value of n. Let us now move on to our example number 4. Given permutation of 7 and r, is equal to 840, find R. So solution, use the formula of permutation, and then by substitution, we can now have here permutation of 7 and R is equal to 7 factorial over 7 minus R factorial. And the answer is 7 minus R factorial is equal to 7 factorial over 840. So this time, 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And I got here 7 times 6 times 5 times 4 because we need to find consecutive factors that the answer is 840. So you can see here from our prime factorization, we have here 10 times 84, and that from 10 times 84, it is equal to 10 simplify 5 times 2. By 84, we have here 21 times 4, and that 21 is equal to 3 times 7. So we have here consecutive factors 7 times 6 times 5 times 4, or we can have 4 times 5 times 6 times 7. And the remaining number is 3 times 2 times 1 because you can see here we can cancel 7, 6, 5, and then 4. So 3 times 2 times 1. So 7 minus R factorial is equal to 3 factorial. And 7 minus R is equal to 3. Therefore, R is equal to 4. Before we leave number 4, let us try to solve it using the trial and error method, or I used to call it the TAE method. So again, we need to find for the value of R. So first thing that you have to do is look for the value of n, and this is 7. So start with the number 7. So I have here descending consecutive numbers starting from number 7 because the value of n is 7. So I have to start with the number 7. And I need to look for the consecutive numbers starting from 7 that the product is equal to 840. So first, let us try to multiply 7 times 6 times 5. The answer is 210. It is not equal to 840. Therefore, it is not our answer. So next is 7 times 6 times 5 times 4. The answer is 840. Okay, so we are done with our goal. We need to find for the consecutive numbers that the product is 840. Now, the question is, how can we find the value of R? Again, we need to find for the value of R. This time, from our consecutive numbers, just look at the smallest or lowest number. So this is very good. The value of R is equal to 4. Again, 4 is our smallest number in our consecutive numbers here. So whether we use the permutation formula and the trial and error method, we have or we can get the same answer. So it is up to you whether you use the permutation formula or the trial and error. We are done with the computation of permutation, or if we are going to find for the value of n and r in permutation. So this time, we now have to find for the value of combination. We have here given combination of 10 and 3. So what is our answer? Solution, of course, we need to use the formula of combination, and again, the formula for combination is Combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. So by substitution, we have here 10 factorial is equal to, or rather 10 factorial over 10 minus 3 factorial multiplied by 3 factorial. First is you have to simplify the denominator. So 10 factorial over 7 factorial multiplied by 3 factorial. Simplify, we can now have 10 times 9 times 8 times 7 factorial. I end up with the 7 factorial because you can see here that in our denominator we have 7 factorial. And then multiply by 3 factorial, it is 3 times 2 times 1. So it is division, so we can cancel 7 factorial. And we can also simplify here 10 and 2. We can divide it by 2, or we can also use the number 8 because it is also divisible by 2. But this time I will use the 10. So 10 divided by 2 is 5. And of course 2 divided by 2 is 1. Okay. Another thing that we can cancel, or another number, is 9 and 3. So 9 divided by 3 is 3. And 3 divided by 3 is 1. So we are done. Okay, so next is the only numbers that are remaining are 10 times 3 times 4. For our numerator and for our denominator, we have only 1, so we do not write it. So I want you to compute for the 10 times 3 times 4. What is the answer? Very good. Combination of 10 and 3 is equal to 120. Example number 6. Given combination of n taken for is equal to 15, we need to find for n. And how can we find for n? So this is one way on how to solve for the value of n. So of course, we need to use the combination formula. And then we are going to substitute the given value of r, which is 4. So you can see here in our solution. And then we have here the answer for combination, which is 15. So it goes like this. 15 is equal to n factorial over n minus 4 factorial multiplied by 4 factorial. By cross multiplication, we have 15 times 4 factorial is equal to n factorial over n minus 4 factorial. So from the left side, it is better to retain them as factors and arrange them as consecutive numbers. And from the right side, think of 4 consecutive factors equal to the factors of the left side. Then observe both sides to find the value of n. So as you can see here, the value of r is equal to 4. So we need to think of 4 consecutive factors. So it is 5 times 3 times 4 times 3 times 2 times 1 is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 multiplied by n minus 4 factorial over n minus 4 factorial. So the answer is 6 times 5 times 4 times 3 is equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3. And then these 4 consecutive numbers are 6 times 5 times 4 times 3, and we are looking for the value of n in combination. So just look for the biggest number in the consecutive factors. So it is 6. So n is equal to 6. Another example in finding the value of n in combination. So I have here the simplest way on how we can find for the value of n. So given combination of n taken 3 is equal to 35, find n. So here is my another solution. So the value of r is 3. So you can see here the value of r is 3. So we expand this as n multiply by n minus 1 and then multiply by n minus 2 because we are looking for 3 consecutive factors over to the value of r. So over 3 factorial is equal to 35. And then cross multiplication. So first we have to evaluate our denominator 3 factorial. So this is equal to 3 times 2 times 1. And then cross multiplication. So we can now have n times n minus 1 times n minus 2 is equal to 35 multiplied by 6 for the 3 factorial. So 3 times 2 times 1 is 6. 35 multiplied by 6. So it is n multiplied by n minus 1 multiplied by n minus 2 is equal to 35 times 6 is 210. Now think of 3 consecutive factors that the answer is 210. So it is 5 times 6 is 30 times 7 is 210. And then from this 5, 6, 7, again 5 times 6 is 30 times 7 is 210. So these 3 consecutive factors, look for the biggest number. So the biggest number here is 7. So the value of n is 7. And if we are going to check if our answer is correct, so combination of 7 taken r or combination of 7 taken 3 is equal to 35. So let us check. Using combination formula, combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. By substitution, we can now have 7 factorial over 7 minus 3 factorial, 3 factorial. And then simplify. So we now have here 7 times 6 times 5 times 4 factorial. I end it with 4 factorial because in our denominator, 7 minus 3 is equal to 4 factorial. So, and then multiply by 3 factorial. So this time we have here combination of 7 taken 3 is equal to 7 times 6 times 5 times 4 factorial over 4 factorial multiply by 3 factorial. And this is division, so we can cancel 4 factorial here and the 4 factorial in the denominator. So we have 7 times 6 times 5 over 3 factorial. So this is equal to 3 times 2 times 1. And then, again, this is division. So we can simplify or divide 6 and 3. And then, if we are going to divide 6 divided by 3, the answer is 2. And then 3 divided by 3 is 1. Okay. And then you can see here that we can cancel 2 and 2 in the denominator. So this time, the only remaining numbers are 7 and 5. So combination of 7 taken 3 is equal to 7 times 5. And the answer is 7. Combination of 7 and 3 is equal to 35. So therefore, our answer is correct. So this is the simplest way on how we can find the value of n in combination. Let us have another example. Given combination of n taken 2 is equal to 78, find n. So this is the simplest way on how we can find the value of n in combination. Again, the given here is combination of n taken 2 is equal to 78. So in finding for the value of n, take note of the value of r. So we have here 2. So for our first step, for the numerator, start with the n and then multiply by n minus 1. So this is for the first consecutive factor and this is for the second consecutive factor. Again, because of the value of r is equal to 2 over to the value of our r, which is 2. So this is 2 factorial and then it is equal to 78. So by simplifying, we now have n multiplied by n minus 1 over 2 times 1 from the 2 factorial is equal to 78. So 2 times 1 from our denominator is 2. By cross multiplication, we have here n multiplied by n minus 1 is equal to 78 times 2. And the answer is 156. So this time we are looking for 2 consecutive numbers or factors that the answer is 156. So let us try if 10 times 11. So 10 times 11 is only equal to 110. So this is not equal to 156. What if we are going to multiply 11 times 12? So this is equal to 132. So it is not equal to 156. So what if 12 times 13? Correct. The answer is 156. So the value of n is 13. From these 2 consecutive factors, the biggest or the largest number is 13. So n is equal to 13. And if we are going to check if our answer is correct, so use the combination of 13 taken 2 is equal to 78. Okay, let us check if our answer is correct. Of course, use our combination formula. Substitution, we can now have 13 factorial over 13 minus 2 factorial multiplied by 2 factorial. And then we have here 13 times 12 times 11 factorial. So again, I end it with 11 factorial because in our denominator, 13 minus 2 is equal to 11. And then copy 2 factorial. So we can now cancel 11 factorial and in our denominator 11 factorial. So the only remaining numbers are 13 times 12 over 2 times 1. And then we can divide 12 and 2 by 2. So this is 1 and this is equal to 6. 12 divided by 2 is 6. So 13 times 6, the answer is 78. Okay, so therefore, the answer is 13. We are done finding the value of n in combination. This time, we need to find the value of r in the combination. Example, combination of 8 taken r is equal to 28. Find r. So this is the solution. Of course, we need to use the formula for combination. Next is the substitution. We can now have your combination of 8 and r is equal to 8 factorial over 8 minus r factorial multiplied by r factorial. So the answer in our combination is 28. So this is 28 is equal to 8 factorial over 8 minus r factorial multiplied by r factorial. So, how to find the value of r? So, from the answer 28, get the prime factors of it. So, the prime factors of 28 are 7, 2, and 2. So, 7 times 2 is 14, times 2 is 28. So, these are the prime factors of 28. And the smallest prime factor will be one of the possible value of r. So, from 7, 2, and 2, the smallest is 2. So, r is equal to 2. So, we can now have one possible value for r, which is 2. And then, there is another possible value of r, which is n minus smallest prime factor. Again, n minus smallest prime factor. Thus, 8 minus 2 is equal to 6. So, I got here from the denominator 8 minus r. So, 8 minus 2 is equal to 6. So, therefore, we can now have two possible factors, which are 2 and 6. And if we are going to check if our answer is correct, so just simply get the value of r. Again, this is 2. And then use this formula. Then substitute for the value of r. So you can see here that 28 is equal to 28. So correct. R is equal to 2. And for the value of r is equal to 6. Again, substitute here the value of r. So this is also correct. So the final answer is r is equal to 2, and r is equal to 6. Another example, given combination of 11 taken r is equal to 165, find r. Solution, we need to use the combination formula, and by substitution we have 11 factorial over 11 minus r factorial multiplied by r factorial. So, 165 is equal to 11 factorial over 11 minus r factorial multiplied by r factorial. Get the prime factors of 165. So, the prime factors of 165 are 11 times 5 is 55 times 3 is 165. And then, the smallest prime factor will be one of the possible value of r. So, in 11 times 5 times 3, the smallest prime factor is, of course, 3. So, we now have here one possible value of r, which is 3. And another possible value of r, which is, again, n minus smallest prime factor. So, 11 minus 3 is equal to 8. So, therefore, we have r is equal to 3 and r is equal to 8. So, this is our final answer. Okay, this time, we are going to solve for the value of r in another simplest way. So, example, given combination of 8 taken r is equal to 28, find r. So, we are looking for the value of r here. So, start with the value of n. So, the value of n is 8. So, write 8 and then give the next lower number after 8. So, this is 7. So, 8 times 7 is 56. And then, it is our first try that 8 times 7 is equal to 56, which is 56 is greater than the answer in the combination, which is 28. So next thing that you will do is to divide 56 over 28. And our goal is to find for the quotient that has its factorial notation form. Okay, so let us try to divide. 56 divided by 28 is equal to 2. Okay, so this time, what is the factorial notation of 2 so that we can find the value of r? So the factorial notation of 2 is 2 factorial because 2 times 1 is equal to 2. So our quotient has a factorial notation, therefore r is equal to 2. Okay, and if we are going to check our answer, so combination of 8 taken 2 is equal to 28. Use combination formula, and then by substitution, we can now have here 8 factorial over 8 minus 2 factorial multiplied by 2 factorial. And so as you can see here in our solution that in the denominator, 8 times 7 times 6 factorial over 6 factorial times 2 factorial. So I only end in 6 factorial in our numerator because you can see here if we simplify 8 minus 2 factorial is equal to 6 factorial. So cancel. And then the only remaining numbers 8 times 7. And in our denominator 2 factorial. So this is 2 times 1. Again, this is division. So we can simplify 8 and 2. So 8 divided by 2 is 4. And then 2 divided by 2 is 1. So the remaining numbers in the numerator is 4 and 7. And if we are going to multiply, 4 times 7 is 28. So therefore, combination of 8 taken 2 is equal to 28. So R is equal to 2. Our last example, given combination of 10 taken R is equal to 120, find R. Again, in finding the value of R in combination, we can use this simple way. So in here, again, we need to find for the value of R. So we should start at the value of n, which is 10. And then, by trial and error, we will list down the numbers starting from 10 and then give the next number lower than 10, which is 9 and 8. In here, we will use the trial and error method. By multiplying 10 times 9, the answer is 90. So our answer or our combination is 120. So we need to find the consecutive factors or the consecutive numbers which is greater than the combination, which is 120. So 10 times 9 is only 90. So we will multiply it with the number lower or next to 9, which is 8. So we will try again. 10 times 9 is 90. Multiply by 8 is 720. So 720 is greater than 120. Is equal to 120, which is our answer to the combination. So in here, 720 is greater than 120. So we will try to divide it by 120. So 720 divided by 120, correct? The answer is 6. And again, the quotient must have its factorial notation form. So think of the factorial notation form of 6. So it is 3 factorial, or simply count these 3 consecutive factors. So 1, 2, 3. So we have 3 factorial, and if we are going to simplify it, of course it is equal to 6. So the value of R is equal to 3. And if we are going to check if our answer is correct, so we have here combination of 10 taken 3, which is our answer, must be equal to 120. So let us check using combination formula. By substitution, we now have here 10 factorial over 10 minus 3 factorial multiplied by 3 factorial. So, simplifying 10 factorial, we have here 10 times 9 times 8 times 7 factorial. So, again, I will end our numerator by 7 factorial because the answer in the denominator here, 10 minus 3 factorial is equal to 7 factorial multiplied by 3 factorial. So again, it is division, so we can cancel 7 factorial and 7 factorial. So, we can now have here 10 times 9 times 8 over 3 factorial is equal to 3 times 2 times 1. And we can see here that we can cancel 10 and 2 by dividing it by 2. So the answer is 5. And in our denominator, the answer is 1. Same with 9 and number 3 here in our denominator. We can divide it by 3. So the answer is 3 and 1. So, combination of 10 taken 3 is equal to 5 times 3 times 8. So, we only have here 5 times 3 times 8 in our numerator. And in our denominator, we only have 1, so we do not write it. So, 5 times 3 is 15. Multiplied by 8 is 120. So, combination of 10 and 3, or combination of 10 taken 3 is equal to 120. So, correct. Our answer is R is equal to 3.